Welcome back. Now we've created a couple of functions for playing an attack montage and getting the montage section. Now we need to be able to play that from here in the behavior tree. So how do we do that? Well, we have move to tasks and we have wait tasks, but if we drag off and open the dropdown for tasks, we don't have an attack task. We need to create a custom task that will do exactly what we want it to do. We can do that by going up to the top here and clicking on New Task. Now this creates a new behavior tree task blueprint, and by default it's called BT Task Blueprint Base New. Now we need to go into our folder where we have our behavior tree, and that's in our enemy controller folder. This is where our new task appears, and we need to rename it because that's not a very good name. So I'm going to call this BTT for behavior tree task underscore attack. So we have this new task and it's a blueprint. So what do we do in this blueprint? In order to make this functional, we need to create a couple of functions. Now, up here in the My Blueprint tab, if you hover over the functions bar, you'll get a couple of options. You can add a new function, or you can override an inherited function. And if you click the drop down next to override, here are a selection of inherited functions to override. Now here is a function called receive execute AI. Click on that and we now have event receive execute AI. Whenever this particular task node is reached in the behavior tree, this is the event that will be fired off. And you'll see that we have the owner controller and the controlled pawn at our disposal, so we can use those here in our custom task. Now there's another function we're going to call after we perform all the actions we need to. So right click and we're going to use finish execute. Now once we reach this function, then our task will be considered finished by the behavior tree. And whatever we pass in for the success parameter is what determines whether or not this task has succeeded. So what are we going to do in between these two nodes? Well, we have our controlled pawn here. And if we drag off of that, we can cast this pawn to enemy BP, which means once this cast succeeds, we then have access to functions on the enemy BP. Let's drag off of this and use our new blueprint callable function called play attack montage. We made this blueprint callable, and it takes a fname for the section name and a float for the play rate. Now we also created a function that is blueprint pure, which means we can call it from here in blueprints, and we call this get attack section name. Now notice the difference between play attack montage and get attack section name. Play attack montage has an input execution pin and an output execution pin, whereas get attack section name does not. It just returns a value. That's because we made get attack section name blueprint pure, and you can do that for functions that simply perform a quick calculation and return a result. That's why we made this one blueprint pure. Now get attack section name is going to return an fname from one of our 4 fnames that have our attack montage sections in them. So we'll get a random section name. We're going to use this and plug it straight into play attack montage. Now we also made the play rate an input parameter, which means we could change this or use a random value at some point in the future if we want to. But for now, I'm just going to use a value of 1, so all of the attack montage sections get played at the normal rate. Now, after we play attack montage, we're going to call finish execute, and I'm just going to use a value of true for the success. So as soon as we play the attack montage, we'll consider this task to be a success. All right, let's go ahead and compile and save this. And now we're ready to use this in our behavior tree. Let's head back into the behavior tree, and here is where we're going to use our new behavior tree task. Now, rather than just execute our attack task, which is going to result in playing the montage, I'd like to execute this attack behavior tree task and then use a wait node so that we're not spamming the character with attacks. That would be too difficult. We want the enemy to wait each time it attacks by a specified amount. That way, the enemy is not attacking just one after the other, making it too difficult for the character. So what I want to do is make use of a sequence node. I'm going to drag off of the selector just in between these two branches here. And I'm going to use a sequence, and now we have a sequence node for this branch. Now remember, a sequence node will execute its children from left to right until one of them fails. So as long as they're succeeding, it will continue to execute from left to right. Now first I'd like to execute our brand new task called BTT attack. So click the drop down, and here it appears in our list of task nodes. Let's go ahead and select that. And now we have this task. Now after we execute BTT attack, I'd like to go ahead and use a wait node. So let's click the drop down and find the wait task. And for wait, I'm going to give this a wait time. Now I'd like the wait time to be 2 seconds plus or minus 1 second. So for the random deviation, I'm going to select 1 second. And now we have a sequence that will execute the attack task and then the wait task. Excellent. I'm going to highlight this leftmost branch and drag it out, just so we have a bit more room here for this middle branch. Now, we do want to make sure that some conditions are met before we execute our attack behavior tree task. For one, we don't want to attack when we're stunned. So I'm going to right-click and add a new decorator and select Blackboard to add a new decorator to this sequence node so that we can make sure that we're not stunned when we're trying to attack. So let's click on this decorator and rename this. And I'm going to rename it isStunned, so we know that this decorator is checking the stunned Blackboard bool key. Now, for the Blackboard key, we're going to set this to stunned, and we only want to attack when stunned is false. So we're going to set key query to isNotSet. Now, we're going to have our notify observer set to onResultChange. So I don't want to just abandon this branch when the value of our stunned bool key changes. I only want to prevent this branch from being executed when we try to evaluate the condition stunned is not set. Now for observer aborts, we're going to select self, and you'll see that this entire branch turns green, and here in the description it says nodes aborted by mode self. So you'll see that this entire branch will be aborted as soon as this result is evaluated and it determines that stunned is set to true. So our selector is going to execute its children until one of them succeeds, which means as long as our target is set, then this leftmost branch will fail and we will attempt the second branch, right? Now, if we're not stunned, then we're just going to attack. But that's not enough. We also need our enemy to be in attack range. So what we can do is right-click on our sequence and add a second decorator. We'll select Blackboard and click on this second decorator, and we're going to rename this one, and we're going to say in attack range. And so now we can have two conditions that both must pass if we want this sequence node to execute. Now for in attack range, we're going to use our in attack range bool key, which means Blackboard key needs to be set to in attack range. And for this one, we want in attack range to be true. So we're going to leave key query set to isSet. Now, just like isStunned, we're going to notify observer on result change, and observer aborts will be set to self. That way we'll abort this branch if we evaluate the condition and in attack range is false. Let's go ahead and save and give this a try. We're going to go ahead and hit play, and let's aggro the enemy. Here it comes. And we now see that the enemy is attacking. Now I'm going to hit Shift F1 to get our mouse, and I'm going to open the behavior tree. And you'll see here that what's happening is we're reaching this attack task node, and then as soon as we execute it, we go straight to the wait. I'm going to undock this and set it right here. Now our in attack range decorator should fail if we get out of the attack range. So what I'm going to do is run away and now take a look at the behavior tree. We now have the third branch being executed, which is checking to see if we're stunned, and if the enemy is not stunned, it's calling move to. Now if we shoot and the enemy is stunned, then that third branch fails as well. In which case, all three branches are failing and the enemy stands there playing that stunned hit react animation. We now have three branches in our behavior tree. we have our patrolling behavior, our attack behavior, and our chasing behavior. Now, before we wrap this up, one thing I'm noticing is as soon as we get close, the enemy is blocking our camera, which is causing the camera to zoom in, and that doesn't really look that great. Now we can fix this by setting the collision settings for the mesh on Grux. So we can do that from C++. So let's go into the enemy.cpp class file, and let's go all the way up to begin play. Now here in begin play, we see that we get our mesh already, and we're setting the collision response to the visibility channel to block. We can also set the collision response to the camera channel. So let's get our mesh, and let's call set collision response to channel, and we're going to select eCollision channel camera. And for this, we're going to use ignore. So we're going to say eCollision response ignore. Now, just so you can see what's going on, let's put each of these inputs on their own line here. Now, our capsule component is also going to be blocking that camera. So we're going to get that capsule component using getCapsuleComponent. And from this, we're also going to set the collision response to channel. So we're going to say set collision response to channel, and we're going to use the same inputs as we used for the mesh. We're going to set eCollision channel camera to ignore. Now, if you hover over this, we're getting the pointer to incomplete class type not allowed error, which means we need to add the include for the capsule component. So here in the Unreal Engine documentation, we'll see that that's in components/capsulecomponent.h. So let's include that at the top of enemy.cpp right there. Now that gets rid of our error. So we're now setting the collision response to the camera to ignore for the mesh and for the capsule. So let's go ahead and comment this and say ignore the camera for mesh and capsule. And we can go ahead and compile this. And we can go back into the editor and let's test this out. So let's go ahead and aggro the enemy. And now if we rotate the camera around the enemy, it's no longer blocking the camera, so we don't get that weird zoom in effect. So this looks really good. And look at the enemy go. It's just wailing and whacking away, and this is looking great. Now we actually need to do something when the enemy hits us with his big stick. So we're going to start taking care of attack mechanics in the next video. I'll see you then.